Okay, so welcome to Chapter 9. We're going to start talking about hypothesis testing. Now, you've heard of hypothesis testing before. You may remember it from your grade school science classes or even your college science classes. When you're doing the scientific method, before you conduct a test, you form a hypothesis of what you think is going to happen, and then you conduct your experiment to see if your hypothesis is rejected or not. So we're doing the same kind of thing here. We're conducting a hypothesis test. Now, we actually have two hypotheses. We have the null hypothesis, which is H subscript 0, and that is the status quo. That's what's currently happening, the default state, if you will. And then the alternative hypothesis, which your book designates as H with a subscript A. I've also seen it designated with H as a subscript 1. Because sometimes we have 2 or 3 hypotheses, so we may have H subscript 1 and subscript 2 and subscript 3 even. This is really what we're testing. This is what we're looking for to see if what happens. So the null hypothesis is what's already presumed, and then the alternative hypothesis is what we are actually testing. So we are going to use sample information, we know this, to make inferences or about the population parameters. And so we're going to use our hypothesis testing to determine if our sample contradicts the null hypothesis. So we only have two options here. We can either reject the null hypothesis or we do not reject the null hypothesis. Notice, however, that we do not accept the null hypothesis, and we don't accept or prove true the alternative hypothesis. So if we reject the null hypothesis, we say the sample evidence does not show that the null hypothesis is true, but that doesn't necessarily mean that the alternative hypothesis is true. So we only make a decision about the null hypothesis. We either reject it or do not reject it. So when we're talking about the null and the alternative hypotheses, notice that we're going to use symbols. So equal, greater than, or less than, or equal to are what we're going to use. So in the null hypothesis, it's always the equals, okay? The alternative hypothesis is then that it does not equal, or it is greater than or less than, okay? But the null hypothesis always includes the equality. You can't write it the other way. Now, when we test this, and we're going to get into this later in this chapter and then continue on in future chapters, we'll either have a one-tailed test or a two-tailed test. So a two-tailed test is when the null hypothesis has an equal sign in it. So for example, if the null hypothesis is that the mu equals the mu, then the alternative is it does not. So that's a two-tailed test because we're checking in both tails of if you think of the normal distribution bell curve. A one-tailed test has that greater than or equal to or less than or equal to. So for example, if we're saying that the mu of the null is greater than or equal to the sample or the population mu, then our alternative is no, that the population is greater than. So this is a one-tailed test because we're only testing in one tail. We're testing just if it's greater than or less than. So it's just a one-tailed test. Now, when we formulate a hypothesis, we've got 3 steps we have to follow. First of all, we're going to identify what population parameter we're looking for. Generally, that's the mean or the probability. We're going to determine whether it is a one or a two-tailed test. And then we write our hypothesis so that the equality sign is in the null hypothesis and the inequality sign is in the alternative hypothesis. So we'll walk through a couple of examples. So here we have a trades group predicts that back-to-school spending will be $606.40 per family this year. And so we're trying to see if that is correct or not correct, if we can reject or not reject that hypothesis. See, I just said it wrong myself. So the parameter of interest would be the mean, since we're looking at the average level of spending. Since we want to document if the population differs from the sample, So we're looking at an equal to or a not equal to. This is a two-tailed test. So then we'll write our hypothesis, where our null hypothesis is that the mean is equal to 60640, and the alternative hypothesis is that the mean is not equal to 60640. So notice we're not, the alternative hypothesis isn't saying whether it's greater than or less than, just that it's not 60640. Now in this example, we're told that a television research analyst wishes to test a claim that more than 50% of the households will tune in for a TV special. So let's go through and look at this now. So here we're looking at the probability that more than 50% of households will tune into this TV special. Since we are looking at a greater than or more than, this is just a one-tailed test. And then our null hypothesis is that the probability is less than or equal to 50%. Therefore, the alternative is that the probability is more than 50%. Now, of course, our sample may give us some information and we draw the wrong conclusion. So there's two types of errors that we can commit. The type 1 error is when we reject the null hypothesis, but the null is actually true. So this occurs with a probability of what we call alpha, okay? Whereas a type 2 error is when we don't reject the null, but the null is actually false. So this is what we call beta. Now, for any given test, either alpha is going to be greater or beta is going to be greater. So the only way that we can increase or decrease both of them without increasing the other one is to increase the sample size. So if we want to decrease both the beta and the alpha, then we need to have a larger sample size. And the larger the sample size we have, the less likely we are to commit either one of these errors. So let's look here and walk through some different decisions. So when we reject the null when the null is false, then that is the correct decision to make. If we do not reject the null and the null is true, then again, we've made the correct decision. If we reject the null, but the null is actually true, we've made a type 1 error. And then if we don't reject the null and the null is actually true, if we do not reject the null and the null is false, we've made a type 2 error. So let's look at a couple of more examples here. So here we have the law of the null is the person is guilty. Someone accused in a particular lawsuit or court of law is innocent. And then the alternative is that the person is guilty. So a type 1 error would be we assume, or we conclude that the accused person is guilty when in reality he or she is innocent. So that's a type 1 error. A type 2 error is when we conclude that they are innocent, but in reality he or she is guilty.